Ever just stop and look around? I mean, really look. At your phone, the air you're breathing, even the stars in the sky. What is all this stuff actually made of? Well, it turns out there's this one super simple idea that ties it all together. And trust me, once you get it, you'll kind of see the entire universe in a whole new light. So, let's dive in.
Okay, so let's try a little thought experiment. Picture a rock, a glass of water, and the air inside a balloon. I mean, they couldn't be more different, right? A hard solid, a sloshy liquid, and an invisible gas. But what if they all have something major in common? Any guesses what that could be?
It's super simple, actually. The answer is matter. Yep, that's it. That's the one thing that connects them all. From the hardest diamond you can imagine to the air you're breathing right now, it's all just different versions of the same basic stuff.
All right, so calling it matter is one thing. But what does that actually mean? Like, what's the official definition? To really wrap our heads around this, we need to get to the core of it.
And here you go. The cool thing is, the scientific definition is surprisingly simple. Matter is just anything that does two things. One, it has mass. And two, it takes up space. Has volume. If something checks both of those boxes, boom, it's matter. So let's break that down just a little bit. Mass is basically just how much stuff is crammed into an object. Now, it's not exactly the same as weight, but they're definitely related. And volume? That one's even easier. It's just how much space something fills up. Think about it. A big beach ball and a bowling ball might take up the same amount of space, same volume. But that bowling ball has a ton more mass, right? Okay, so that seems to cover pretty much everything, right? Your desk, your coffee, the air, it all has mass and takes up space. So that kind of begs the question, is everything we experience matter?
And the answer to that is a big nope. Not everything is matter. Just think about it for a second. What about light, or heat, or sound? You can't weigh them. You can't measure how much space they take up. And what about your thoughts? Same deal. That's because they're not matter. They're the other half of the puzzle. They're forms of energy.
Okay, now let's do something cool. Let's zoom in. I mean, way, way in. If you could look at any piece of matter, literally anything, under a super powerful microscope, you'd see something wild. It's not solid at all. It's actually made up of zillions of tiny little particles, atoms and molecules, and they are never still. They're constantly vibrating, bouncing around, just in frantic motion. And get this, the way those tiny particles are behaving, how fast they're moving and how tightly they're packed together, that's what decides what state the matter is in. So let's talk about the three main states that we all know and love: solid, liquid, and gas. First up, we've got solids. So in a solid, picture all those little particles just packed together, super tight, usually in a nice, neat pattern. They can't really go anywhere. They're kind of locked in place, just vibrating with energy. And that's exactly why a solid, like your phone, a brick, an ice cube, holds its own shape and has a fixed volume. Next, let's talk liquids. In a liquid, the particles get a little more freedom. They're still close to each other, but they're not locked down. They can kind of slip and slide past one another, almost like a bunch of marbles rolling around in a jar. And that freedom to move, that's exactly why a liquid takes the shape of whatever container you pour it into. Its volume stays the same, but its shape is totally flexible.
And finally, we have gases. Now, if you give those particles even more energy, they just completely break free. They're like little superballs just zipping around at crazy high speeds, bouncing off everything in sight. And because they're so free and energetic, a gas has no definite shape and no definite volume. It'll just expand and expand to fill up any container you put it in, no matter how big.
So, when you see it all laid out like this, you can spot the pattern, right? It all boils down to how much the particles are moving. The more energy they have, the more they move, from just vibrating, to sliding past each other, to flying around freely. And as that movement increases, the matter's shape and volume get less and less fixed. It's a really simple and elegant idea when you think about it.
Okay, so if the whole thing is about particle energy, that means we should be able to change a substance's state, shouldn't we? And we can. All we have to do is add or take away energy, which we usually do in the form of heat. By doing that, we can make matter jump from one state to another.
And there are 4 main changes we see all the time. You add heat to a solid, like ice, the particles start vibrating like crazy until they break loose. That's melting. Take the heat away from that liquid water, and it freezes right back into a solid. Simple enough. Now add even more heat to the liquid, and the particles start flying off into the air. That's evaporation. And if you cool that gas back down, the particles slow down and clump together again, which is condensation. You see it on a cold glass of water all the time.
Now, here's a really, really important point. When water freezes into ice or boils into steam, it's still water. It's still H2O. Nothing about its chemical makeup has changed. These are what we call physical changes. The stuff is still the same stuff. It's just in a different form. All you're doing is messing with how its particles are arranged and how much energy they have. All right, so we've gone from the big picture stuff we see every day all the way down to this invisible dance of tiny particles. So now, let's zoom back out and ask the big so what question. Why does any of this, well, matter? Well, it's because this isn't just some random science trivia. This is like the basic operating system for the entire physical world. You want to understand weather? You need to know about evaporation and condensation. You want to understand chemistry or biology or how planets and stars are even formed? It all starts with understanding matter. It is literally the foundation for, well, everything. Okay, let's do a super quick recap just to make sure it all sticks. Number 1, matter is anything with mass that takes up space. Got it. Number 2, it's all made of tiny particles that are always moving. And number 3, solids hold their shape, liquids take the shape of their container, and gases just fill up whatever space is available. Simple as that. And that's really the big idea here. Everything you can possibly touch, see, or imagine, from a single tiny atom to a massive planet, it's all playing by these same fundamental rules. So next time you're just looking around, maybe take a second to think about that invisible, super energetic dance that's happening inside of everything. It kind of makes you wonder, right? What do you see differently now?